MergeSort. Let's look at the MergeSort algorithm. It's recursive. And what we'll do is we'll simply visualize it using this nice website, Hacker Earth. Okay, so we have an array of integers. And these are the integers 3, 2, 5, 4, 7, 1. And we want to see what happens when the MergeSort algorithm sorts this array. Visualizing it, we'll slide down. I hit run. It creates the array. Time to visualize. We have 68 steps. All of the steps will be explained here. First step, it selects the entire array. Then it splits it in two. It's going to keep splitting it in two until it can't split anymore, which means the smallest cell is going to be of size 1. So let me go ahead and split again. See how it splits? No, it doesn't have to be even. Because if you have an odd number, you're going to split with 2 and 1. But you keep splitting until you can't split anymore. So now, you see how it splits the left portion all the way down to every single time we get a single cell. Now, this is the base case. This is the base case because you can't split this anymore. So now it's time to merge. And if you look carefully, you'll see it looks at the two and then it figures out which one needs to go in front. Pretty easy, just look at the values and then select the one that's smallest, put it in the front, put the one behind that's larger. And then we look again at the two subarrays and we're trying to sort those. Clearly we're going to sort them by doing the same thing. So this is the merge part of it, which is kind of popping off the stack, coming back up. Now, once this is sorted, it keeps splitting the right. It's going to do the same thing on the left and on the right. So the right side is going to get checked out. The 4 is going to go in front of the 7. And then when you look on the right side, the 1 needs to go in the front because it's the smallest. So you can see how it compares. It checks once it puts those together. So the same thing is coming off the stack again. We have the two subarrays, and we're going to do the same thing again with all of these. The smaller one goes in front, or smallest, and then the second smallest, because we are merging two sorted arrays. See, it's easier to put two sorted things together. That's the idea. So the splitting in two helps bring this down to the smallest possible array. It's a divide and conquer algorithm. It's kind of breaking it down into small cells, and once we get the small cells, it's easier to work with smaller pieces. And then we put it back together, because it's kind of like a puzzle. So you can see how it all just works out. It splits, 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 then it merges. It merges smaller arrays or subarrays. And then once we're all done, the whole thing is completely sorted. Remember, we started off like that. Now it's completely sorted. Let's take a look at the code and wrap this up. All right, so in the code, you could see the merge sort here. The reason why it's written like this is because all the different pieces are helpers. We don't expose the indices. So when this gets called, it's going to get called from 0 to length minus 1. That makes sense. That's the entire array. Here's the merge sort. Split in two. See, go to the left and the right. Look at the split in two. Right here. Left split, right split. Then merge. And the merge is on the bottom. The merge is not recursive. The merge is iterative. And it's all loops. So we're looking and checking and looking and checking and making sure the values that are supposed to be in front are in front and the ones that are supposed to be behind. This is going to be the part that's popping off the stack coming back up. You can pause the video here and check to see if you can figure out how this works. We're playing with all indices, so just moving things around. You can see here on the left side, the array values are changing based on who is smaller and who is larger. So let's take a look again to wrap this all up. When the merge sort gets called, we hold the temporary array. We call merge sort, which is the actual recursive method. This splits it in two, left half, right half. Look, we're starting at 0, stopping at the middle, then the middle plus 1 to the end. That's the right half. We keep doing this recursive. Remember, the method is calling itself. That's why we saw those splits in the visualization. So every time it splits until it can't split anymore. Once it can't split anymore, then we are merging, coming back off the stack. Right here. Okay? So once you're finished running this algorithm, the entire array is sorted, but it's done recursively. This is merge sort. That's it.